Good evening. I come from Sweden. My name is H.Sverdrups. I will take you through a talk today, which I've composed together with a colleague, Dennis Kodja, and my colleague, Vala Ragnarsdottir from Iceland. I will start with a small story of a game you know here in Russia quite well, the game of chess, that was invented in India 2,000 years ago. And when the inventor came to the Raja and he said, I've invented a game for you, then the king said, you can choose your own reward. Tell me how I should pay you for this game. And then the man said, I want you to give me 1 grain on the first square, 2 grains on the next square, 4 grains on the next square, and until we cover the whole game, and this is my payment. Then the vizier of the Raja said, be careful, Lord. This is going to be more grain than there is in the whole world, because the amount rises exponentially. It would be heavier than a planet. Now we look at how we use resources in the world today and how we've done in the last 200 years. Here on the scale, you have years, and here, oh, wait a minute, sorry. Here we have exponential scale. These are the different metals, molybdenum, nickel, platinum, and they're straight lines. They rise exponentially. If we continue this, each line will be heavier than a planet. It's obvious this cannot continue. It will stop. We can look at burn-off rates for all different metals and materials. We try to look at the 40 most important. So what is a burn-off rate? The total amount we know we have on the planet divided by how much do we take out now. And then we get a number of years. And what you see here is, if it is red, we have burn-off rate less than 30, 40 years. 30, 40 years. That's very short. It's no good. I put it red. No good at all. The orange ones are up to 100 years. Well, 100 years, that's not far away. It's also very fast in the life of a nation. On the top here we see different recycling rate. This is business as usual. This is recycling half of everything, and it's still not good enough. And these are many. Look at them. These are iron, aluminium, nickel, copper, zinc. Zinc is 20 years. Nickel is 42 years. Cobalt, 100 years. Helium, 9 years. It's going very fast. We're using far too much. We can look at something called Hubbard curves. These were developed for oil extraction, but they work for all resources. And we can see, when do we reach the maximum? These are again many. It's gold, silver, copper, indium, lead, zinc, iron, molybdenum, chromium, so forth. We can do all of them. When we reach the top, we have taken out half of everything there is on the planet. Now, in exponential growth, you can have the number 70 in your mind. Divide that by the percentage of growth every year. So if we have 3% growth of consumption, divide 70 by 3. So in 20 years, we double. Which means in 20 years, we will use as much metal as we used in all the years before in history. And the next 20 years, we use again if we should continue. But when we reach the top, there is not that much left. We have an example that it doesn't need to be like this. We have the metal gold. Gold was the first metal that man found on Earth, our oldest metal. We had it around for 5,000 years. In those 5,000 years, we have dug up 160,000 tons. Now, if we count through all the gold in the world that we have here and in a bank and where it is, we can find 148,000 tons. So in 5,000 years, we lost 7%. So we do not need to waste it all. And there are ways to map it and to model it, which is going on in some universities where we try to look at how the fate of different metals and materials. And we need to model the physical market, but there are also, which we need to be aware of, that in the financial market there's also a virtual market. And this is a problem for us, that they trade with metal that does not exist, a part of modern banking world. And we can use this to come through with how prices and availability are done. Now this is an example of how we can do it for one metal. What is going on is that there are being different models made for different sectors of how we use materials and energy in society. 30 years ago, there was somebody that wrote the book called Limits to Growth. They made a model to look at the future of energy and metal and resources use. And they predicted then that it would go through a peak, and they were very heavily criticized for it. It's 30 years ago, and it stopped then many years ago. Now we're starting to do this again, because we realize that some of these resources have gone through the peak. Oil has passed the peak. Gold has passed the peak. There are more metals that have done this. Helium is 20 years past the peak. We need to do something about it. So what we're going on now is to try and look at the whole chain, not only from looking at end-of-pipe solutions or clean production, where we look at environmental degradation, or metal use, or metal included in consumption. We look at sustainable consumption. But maybe we need to pull it all the way over to population. The same equation as Bill Gates had. Population times consumption and so forth. If we reduce consumption per capita, but the number of persons are still increasing, we're not winning the game. And today we're actually losing it. We are reducing use, and total consumption is still going up. So what we're trying to do now is recreate what they did then 30 years ago and build a more advanced model for how does the whole household of the world look like, in order to look at energies. Then they didn't look at individual metals or phosphorus. Now we're trying to do this. Now we have better data and better ways to do it. We're using something called systems analysis and system dynamics to do it. And with this, we would like to see the coupling between the metals and the phosphorus and the oil and the coal and the energy and all of these, because they are dependent. And we cannot do them separately. And this is some of the outputs we're then getting. We can couple oil production and oil reserves that go down with population changes, population development, how the soils will develop, because we're going to have food stability and be able to feed these people. In order to run agriculture, you need energy, you need phosphorus, you need metals. All of this is needed. So it's all coupled system to see if we can solve the problem of sustainability. The outputs of the simulations are quite troubling. We had the first outputs coming something like 2 years ago, and I was very worried. I thought, did I do some mistake here? It's crashing. So I tried to look through everything and do more runs. No, it still crashes. Still, it doesn't look pleasant at all. And every time I used, yes, exponential growth in economy and so forth. Well, that kills the development by itself. We run everything empty if we do that. We have to change the whole economic paradigm of growth. We've come to the end of the world in the sense that now we've come to the planetary capacity, and asking for more, it is not there. And we can see that we're actually now going through global coal maximum is here. Peak coal is 3 to 4 years away. Peak oil already happened. The maximum year is 2007-2008. You can control it yourself and look at the oil company statistics. Since 2008, there is 3 to 4% less oil produced in the world every year. Next year will be 3 to 4% less. Now, oil is a major driver of economic growth. And peak coal comes, this is peak energy. So I get something, and this is not my numbers, it's the coal and oil companies' numbers if you take and add them all up. So even the coal companies, it's their numbers. This is what they plan to do. We can do the same for phosphorus. And there's a peak of phosphorus around now. It was last year or this year or next year, but it is in this period of, or this decade is peak phosphorus. Now take a few seconds and think about what peak phosphorus means. Peak phosphorus is the main driver of food. It has no substitute. We cannot eat lead or iron. There has to be phosphorus. Now, the consumption of metals and oil and so is different between the different social classes, the golden billion or the poor. But food is per person. And a rich man does not eat very much more than a poor man. It's marginal differences. So this we need to take very, very seriously. Today we recycle 16% of all the phosphorus we use. It's a linear world. And I would now like to come to where does wealth come from? So, creation of value in society and the driver behind prosperity and money. A major driver for that is energy, which allows us to do materials and to do phosphorus, which allows us to do food, which allows us to produce people. People is made of energy and phosphorus. That's what we're made of. And we're using so much energy that 70% of the people on Earth are made of oil. And this is used, energy, materials, and people, to create work and wealth, which carries up our civilization, which creates creativity, and this is how our society runs. So what happens when we have peak energy and peak phosphorus, and peak materials? Well, what happens, this is what I call a causal loop diagram. It's a link between cause and effect. So we look at the resource base, which leads to resource extraction. As we extract, we take away resources. Leads to consumption, which is, as earlier, leads to wealth, and to life, wealth to life quality, and to complex infrastructures in society. So as we take resources, we get rich, and we build a lot of stuff. Buildings and organizations and societies and Moscow and highways and railroads and ships and everything. And so what happens is we have a rise in resource extraction, and it comes over the peak. We have a rise in wealth. It is delayed 10 to 15 years after the resource peak. And as we have a lot of money, we build a lot of stuff, and we have a lot of costs. So now, here, costs are coming up, costs are going down, and our costs are up. And we get a typical overshoot. High costs and low income. And this is a problem. This is when we get a financial crisis. This is why a financial crisis goes all the way back to resource exhaustion. And it actually happened in the past. It happened in the Roman Empire. We can actually backtrack it. The Romans gained resources by taking new territory, using the resources, build society, organizations, infrastructure, aqueducts, roads, armies, and so forth, take a new territory, until expansion didn't bring more. They came up into forests in Northern Europe. There's nothing there. They came into deserts in the east. There's nothing there. So the expansion didn't bring more resources. So their income fell down. But now they had huge structure and huge cost. And in the end, they had huge cost overrun, couldn't pay the bills, borrowed a lot of money, couldn't pay the loans. And away goes the Roman Empire. We can see these from archaeologists. We can reconstruct these curves with income, state income, and then state costs, and crash. Roman Empire's over. It happened in the British Empire as well. Again, the British Empire was driven by coal. The British were actually quite clever. They invented industry 100 years before everybody else. Industrialization had a fantastic development. All was coal-powered and steel-powered. They acquired a colonial empire, so it's a little bit like Roman Empire as well. More and more territory until that stopped. And so they went through coal maximum, metal maximum, phosphorus maximum around here. 15, 20 years later, that was their maximum wealth. It was when the Second World War started. And of course, the Second World War, as you know, was very expensive. The British, on the Western side, the British paid most of the bills, did most of the job. And since they had then income going down and costs going up, it ended. The British Empire ended. The British were smart. They dismantled their empire before it collapsed. So Britain survived. On the global level, what does it look like? How does our resource base look? When you look through it, I found some very, very scary numbers. Look at fish, ocean fish. 2000, we had fished half of all the fish in the oceans on the globe. Now that's not good. Half of it. The soils peaked in 2005. Now we're not creating more agricultural land than we're actually losing through soil saltification, soil erosion, and so on. We're having less and less soils. Now that's worrying. That's irreversible. Can't do that. Oil peaked, phosphorus peaks around now. Metals started 2002 and are now rolling forward. So if we continue business as usual, we will become like Roman Empire again. But this time it's the planets. Now we need to watch it. And how much time do we have? Well, I think global wealth will maximize around here. And this is when we have the cost overrun. This is the time we have. Within this time, we need to change. We need to change a lot. And you can see here, for different empires, what are now the different collapses, rise and fall, of the Roman Empire, for fun we can run it on all the different empires. There are still empires around. And they don't have much time. Maybe the whole idea of empire has passed its best before date. Maybe that whole thinking needs to go away. Today, the world is linear. If you look at phosphorus, almost all we send in 100, actually we send in 150 million tons every year of phosphate rock. On the backside, 140 million tons are just thrown away. Goes to garbage heap, goes to ocean, goes away. And if we continue like this, it stops after 80 years. This is how it must be. We need to create a circular society. What goes out at the back needs to turn, go through recycling, and come in through the door again. We need to make a closed loop society, closed loop factories. Then we can extend these times. That was what happened when we went in that table. When we went over to the green side of the table on the burn-offs, that was when we do 75 or 80 or 90% recycling. Then it works. Then we can have billions of people, we can have many countries, we can have the standard of living we have, but not with business as usual. That means that the whole idea of economic growth will have to decouple from resource use as such. This is what Armory Lovins talked about as well. And external fueling of just using resources, that will stop. And it's not a choice we have. It will stop for sake of mass balance. And so, if we're going to conclude, what has happened is that everything is at stake. Everything is now up for game, over, unless we change. And then we're now on the game over track. And there are large challenges to be met. So we can conclude, when resources peak, so do wealth, with a delay. The way we do trade today, with speculations with it, and so forth, that destabilizes our markets. So we even have wrong signals. Like I looked at the gold market. In the gold market, there's 15,000 tons of gold available for trading, but the banks are trading with 90,000 tons because they invented 75,000 tons on futures and derivatives which don't exist. This makes the economic crisis worse, makes the economic bubble worse. But they don't only do it with gold, they do it with nickel, aluminium, grain, coffee, tea, you name it, and they do it. This needs to stop. And we can look at economic growth as we reported today with the gross national product. Now, some years ago, the Prime Minister of Sweden, Olof Palme, was murdered in the city. There was a huge investigation, very expensive, trying to find the murderer. And GDP went up. Now, did quality of life go up when the Prime Minister is murdered? No, it doesn't. So it's not a good measurement. Actually, it doesn't work. Some countries have reported growth over the years when they didn't have it. United States had peak oil in 1971, they had peak coal in 1992, and after about 1986 they had declining net wealth production. They reported growth through the whole period because the difference was covered up with loans. Now, growth in loans is not growth in prosperity. And actually, this is what we see is part of the problems with the financial crisis today, is that when end of resource come, if you cover that with loans, it makes it worse. It doesn't make it better. It's just financial cosmetics. So I think we need to act now. We don't have much time. 20, 30 years, then we must be ready. Big changes take a lot of time, so we need to start now. Probably next Tuesday we need to start if we're going to make it. And then we need to work very, very, very hard in all countries. As Alexander said, Russia is a country that has huge possibilities if you can use them right. There are 3 large territories on the earth that has still a lot of resources left. One is under Greenland, a lot of ice, can't get it. One is under the South Pole, 3 kilometers of ice. No, forget about it. And it's Siberia. These are the 3 last treasure chests on the globe left. Now you have one of those. Take very good care of it. Don't burn everything right away. Make now a plan for the next, well, how long should Russia last? 300 years? 500 years? 1,000 years? Make it last very long. And I think these are our challenges for the government. In all countries, corruption and poor governance is a huge problem. If you want to solve technical problems, you have to have proper conditions in society. Be able to make companies, do responsible production, have proper legislation. All this needs to be in place. And if you don't have it, you have to ask for it. There is inadequate legislation where we look at waste as garbage, something bad. Now when you see these curves go up and down like this, when we pass the top, it means for metals that there are now more metals in the city than there are metals in the mountain. So I asked my friend, if I have in front of me a lorry here with the best gold ore from a mountain, and here I have a lorry with mobile telephones, which one do I take? I take the mobile telephones. They have 200 times more gold than the best ore. So I think the mining of tomorrow is urban mining. For many metals, I should turn around and not look at the mountain, but look into the city here in Moscow, and that's the best mine you can have. For many metals, there's more metals there now. Thank you for listening.